Welcome back to Nailing Negative Numbers Now. We've already nailed adding rational numbers and subtracting rational numbers. Today we're going to focus on multiplying and dividing. Yep, I've decided to combine our last two objectives. When you think about it, multiplying and dividing go hand in hand. Just like addition and subtraction. The only difference is subtraction can get a little tricky with those negative numbers if you're not careful. Okay, so what we're going to do to get started today is make sure that you found a quiet area to work. Make sure that you also have a paper and pencil handy and whisper to yourself, I can do this. And don't forget to remember that you can. Did you know that we can choose a 0 point and then positive and negative numbers can represent positions to the right or left of this 0 point? If this sounds familiar, it's because it's listed in your notes. That's what we're going to be focusing on today for the beginning part of this video. Velocity is a combination of both speed and direction. A positive number would mean some speed in the right direction, east, and a negative number would mean some speed in the left direction, west. Take a look at the table on the right side of your screen. You'll see time listed in seconds and distance listed in meters. In 1 second, we can travel -5 meters. So the first thing that I want you to understand is that our speed is 5 meters per second. Our velocity is -5 meters per second. What's the difference between those two terms? Velocity includes both speed and direction. Now, how did I figure out what my speed and velocity was? So the first thing that I did, these are really easy numbers to work with. So I can look at my constant of proportionality. And if you need a little reminder of what constant of proportionality is, think about what that factor is that you're going to always be multiplying x by to get your y. Okay, so in this case, our constant would be -5. And we're going to learn about those multiplying those negative numbers in this video. Okay, now in your notes, you saw a set of rules there. Okay, positive times a positive is obviously positive. A negative times a negative is also positive. So when those signs are the same, you're going to get a positive product. Okay, the same is true with division. All right, but when those signs are different, like a positive times a negative, you're going to get a negative product. While we're here looking at this table, let's also think about division, okay? Our numbers were easy to work with, so we could quickly look at the 1 and determine what would we have to multiply it by to get -5. But what if our numbers weren't so easy to look at? In that case, I really want you to think back to how to calculate your constant of proportionality, aka our unit rate, okay? How do you do that? Well, you're going to divide your y by your x. And in this case, our y is distance and our x is time. So I could write my distance, which in this case is -5, over my time, which in this case is 1. Now, I just told you that whenever we are multiplying or dividing those opposite signs, our product or quotient is going to be negative. Okay, so we're dividing a negative by a positive number, which means our constant of proportionality is going to be negative. Well, we already determined that anyway, right? It's -5 meters per second. All right, let's dig a little deeper. A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive and to the west are negative. To make this a little easier to understand, I put a little picture of a camera up there so we know where it is and how it relates to this scenario. They told us in the introduction that positions to the east of the camera are positive, and then positions to the west of the camera are negative. And we can clearly see this just by looking at our table, right? So since this camera is set up to record the speed and the direction of the car as they pass the camera, what direction do you think the car is driving as we go from this first position to this last position down here where my car is? If you guess that the car is traveling to the right or east, then you're correct. We can see clearly that our numbers are getting larger. We start at a -180 feet, and then we end up at +120 feet. But what do these numbers mean? If I'm at a position of a negative 180 feet, what does that mean? If you think that it means that I am 180 feet to the west of the camera, you're correct. The negative 3 seconds means 3 seconds before I reach the camera, 3 seconds before I pass that camera. What about the 120? That means we are 120 feet east of the camera. And that too represents how many seconds have passed since I passed by the camera. So we just confirmed that we are traveling east, right? But what is the velocity? What is the velocity? We figured out our direction. Obviously, we're going to the right, so that means it's a positive number. But now let's take into account how far we're going in a specific amount of time. So what do you think we should do? Let's divide our position by our time. So if I take negative 180 and I divide it by negative 3, recall the rules that I just shared with you that you can also access in your notes. Negative 180 divided by negative 3, well, that's a positive 60 feet per second, per 1 second. And we can see this illustrated between each of these situations. All right, if I multiply my time by my velocity in each of these situations, I'm going to get my position. So that's what we're going to practice on this next slide. All right, we have our velocity for car C is 25 meters per second. It's been 10 seconds since we've passed the camera. So what would our ending position be? Well, if we're traveling 25 meters every single second and 10 seconds pass, we need to multiply our velocity times the time. That's how we get our ending position right here, this positive 250 feet. All right. And so, I always like to add that equation in there so we can kind of see what it is that we're doing. Let's look at car D. We have a negative velocity. So that means that we're traveling which direction? West. Okay. We have a negative velocity and 30 seconds have passed. So I'm going to go ahead and put our equation down here first while you're thinking about our ending position. What'd you come up with? If you said negative 600, then you are correct. Let's look at the next one. We have car E, who's traveling 32 meters per second and negative 40 seconds have passed. Now, what does that mean? If the seconds are negative, really, what does that even mean? Well, if you said that it's 40 seconds before we reach the camera, then you're 100% correct. The fact that we're traveling 32 meters per second and that number is positive lets us know that we're traveling to the east. So now if we want to calculate our ending position, what do we need to do? We're just going to multiply. We're going to multiply our positive 32 times our negative 40. And we're going to get negative 1,280. So where is our position when negative 40 seconds have passed? We're at negative 1,280 meters. That's where we are. All right. Now let's look at car F. Car F says that we're traveling negative 35 meters per second. So we know we're traveling to the left or west, and we're also at negative 20 seconds. So we haven't even reached the camera yet. So how do we calculate our position? We're going to multiply 35 times negative 20, and we're going to get a positive 700. We're going to get a positive 700. This is interesting, right? So we have a negative velocity. It's 20 seconds before we pass the camera. That means we started on the right side, right? We started on the right side of the camera. It's 20 seconds before we even get to the camera. We're traveling at a negative 35 meters per second. So we're heading to the left. Our position is 700 meters. All right, let's look at car G. So we have a negative 15 meters per second as our velocity, and it is 8 seconds before we pass that camera. How do we calculate this ending position? We're going to multiply negative 15 times negative 8, and we're at positive 120. Positive 120. The main thing I want you guys to really understand as we're working through this lesson today is just really remembering those rules, okay? So when we have those same signs, that product is going to be positive. That's whether you're multiplying or dividing. When you have those opposite signs, a positive and a negative, those the product and the quotient will also be negative. All right, so let's take a look at another example. Around noon, a car was traveling negative 32 meters per second down a highway. Well, if it's negative 32 meters, what can we conclude from this? That we're traveling west, right? At exactly noon, when the time was 0, the position of the car was 0 meters. So recall in our previous example how when we knew our velocity, we could multiply that times our time to find our ending position. All right. So we have negative 32 meters per second. For the first one, negative 10 seconds have passed. So that means we have not reached the position that we'll be at noon. Okay. Now, I know that probably sounds kind of funny, but I want you to think about it like this. Remember in the beginning, I told you we can set any origin or any 0 point, and then any position to the left, would represent those negative numbers or traveling west in this case. And any position to the right would represent those positive numbers or traveling east. Okay. So we're traveling negative 32 meters per second and the time is negative 10. So what is our ending position, or what is our position? What we're going to do is we're going to multiply negative 32 times our time, the amount of time that's passed, and we're going to get a positive 320 meters. We're going to get a positive 320 meters. The same thing is true whenever we are figuring out our position at negative 7 seconds. We're still going to just multiply negative 32 meters per second times the negative 7 seconds. And let's not forget what that negative 7 means. It's 7 seconds before we reach our position that we're going to be at noon. All right. And we can continue the same exact process all the way down our table. The same exact process where we're just multiplying our velocity times our time to determine our position. So I'm going to go ahead and complete the table, and I want you to work on doing the same and then meet me back here to check your answers. Now that you completed your table, what did you notice? Did we confirm that we were traveling west? Did our position go from positive to negative numbers? If you answered yes, you're correct. Now, how can we relate this to division? The same way that we were able to use our velocity and our time to calculate our position, if we had known our position and let's say our time, we could calculate our velocity. So take, for example, our position at negative 10 seconds. I could take 320 meters and divide it by the negative 10 seconds, and I would get negative 32 meters per second. Okay. I could also do that if I knew the position and the velocity. I could calculate how much time had passed, or how much time before we reached that point that we labeled as 0. So as I mentioned at the beginning of this lesson, multiplication and division, they are inverse operations. They go hand in hand, and their integer rules are similar. Okay. So when you are multiplying numbers that have the same sign, the product is going to be positive. If you divide numbers that have the same sign, the quotient is going to be positive. The opposite is true if you are multiplying numbers that have opposite signs. So you got one positive and one negative. The product is going to be negative. If you are dividing numbers that have opposite signs, the quotient is going to be negative. You know what time it is. It's time to check your knowledge. Let's see if you've nailed it.